Let's look at a couple more series parallel combination circuits and just try to develop our skills dissecting these and kind of visualizing how to break them down into simpler circuits. So first one we're going to look at right here is very easy. You can kind of see you can't do a whole lot with resistor 1 yet. But if I find the values of resistor 2 and 3 together, I can see that they're in series with resistor 1. So I could combine them like that. So right here you can kind of visualize that these parallel ones could combine for a single resistance value. So step 1 for this would be to find the resistance value for resistor 2 and 3, which is the parallel resistance formula. So I just plug the values in for those resistors that I'm trying to consolidate. And if you plug that in, 1 divided by 560 plus 1 divided by 1000, and that gives us a total of 358.974 ohms. Now at this value, strictly being in series with R1, I can now just add these two together. So that's going to give me 458.974 ohms. So the resistance total for this simple combination circuit here is 458.974. And you can see all we did was consolidate these two first, and then with that in series, consolidated the overall value. So that one's pretty easy. But let's also look at one that's a little bit more steps involved. So here, again, you kind of have to develop your visualization for how to step-by-step simplify this. And if you look at which resistors you can do something with, the only real option you have here is that you could add these two values together. Because both of these are in series with R4, but you can't do a whole lot with it at this point because you don't have a combined value for R2 and R3. So I would look at this and see, okay, if I combine R2 with R3, I'll get a single value, and then I can combine that value with R4 using our parallel resistance formula. So R2 and R3, that's pretty easy since they're in series with each other. I can just go ahead and add them together. Now, one thing I'd like to caution you about, and this is a great example of it for this problem, is paying careful attention to the prefixes of your units. It's a good practice just to break everything down and type it all out in your calculator. So this 11.5 I got in kilo ohms is really 11,500 ohms, right? If we move this over 3 decimal places, we get this value. You can keep them the same and just leave it like this for now, but pay attention over here for R1. Look at this value. That's the only value that doesn't match any of the others. So when we're combining these, we need to pay attention to their units. If I were to just add that 11.5 to another number that was not in kilo ohms, it was just in ohms, I'm going to get a made-up value that doesn't really make sense because I'm not comparing apples to apples here. So just pay attention to your units, and this is a good example on how you could get so focused on these new concepts you're learning, you forget some old ones that are very, very easy to forget. So again, summarize, just pay attention to your units. So since we have kilo ohms for both these values, I've combined R2 and R3 to get this value. Now this value is in parallel with this value. So the value of R2 and R3 is in parallel with the value of R4. So if I combine these two, I'm just going to be using our resistance in parallel formula. And let's go ahead and punch that in and see what we get here. So 1 divided by 11.5 plus 1 divided by 4.7 and you're going to get 3.336 ohms. Kilo ohms. See how easy that is? All right, so the combined value for these two being 3.336 kilo ohms. This value here is pretty much just in series with these other two values. So being in series, we can just add them up, and that'll give us our resistance total at that point. Again, when we add them up, we can't just add 3.336 to 330 because our units aren't the same. So let's convert it all to ohms now. So we got 330 ohms for resistor 1. We're going to add that to 3.336, so 3,336 ohms for the combined resistance values of the other resistors, plus 10,000 ohms based on the prefixes we see here. So this is going to give us our resistance total. So if you add all that up, you get your resistance total. That comes out to 13,666 ohms. Or the best way to indicate that would be 13.666 kilo ohms. All right, just practice visualizing and breaking these down, and then once we finish that and everyone's pretty comfortable, we'll start looking at how to break it down even further now that we have that information.